Finally. Hello, everybody. My name is Martin Ohl. I'm solution architect in EMEA. So work for McAfee for more than 6 years right now. And I hope you like my wonderful German accent. So originally German. I lived for a while in Ireland for 2.5 years and now in the Netherlands. So now based out of Amsterdam. So over a couple of years, we've done a lot of work with, in particular, the MISP platform. Why? Because it's a customer demand that we had. So we had a lot of customers that ask us from an enterprise, and I'm as a solution architect, I'm more involved in government regulations, similar to government cert or institutes, finance institutes, where there's a huge push into the level of leveraging better threat intelligence and leveraging platforms like the MISP platform. So over the past, we also looked at how does an intelligence platform really works within the McAfee ecosystem. That's also the title of the presentation. You will see a lot of McAfee acronyms and terminologies. I apologize for that up front. But I try to align this also to industry models that you see out there in the market. And at the end, I have some examples how customers or even government cert institutes leverage today the MISP platform in a complete kind of architecture design. But don't see it really as the technical architecture. We talk more about the processes of leveraging threat intelligence and leveraging the MISP platform, and in particular leveraging and aligning this to industry models. So let's look at the industry models that are out there. There are two big ones out there right now, so that are that you see. So that is what you call SOPA and SOAR architecture reference models. One created from ESG a while ago in 2017, and one from Gartner. So I think if you talk about security operations and you talk about leveraging threat intelligence, you might have heard about these models. Where, to be honest, the model of the ESG group SOPA is way much more advanced than the architecture from the Gartner. So this is where we did the mapping. What calls a mapping? Apologize for the slide up front. You will see a lot of acronyms from McAfee. But basically this describes all the different levels and layers in advanced security operations teams needs to have. And that really starts with, do we have the right sensoring capabilities within the enterprise? Do we collect the right data? And this is basically the baseline. So do we have the right malware sensors? Do we have the right data sensors? Do we have the right information and deception, maybe honeypot sensors that provide SOC with intelligence and visibility? But as you go up, I don't want to explain every single terminology that you see, but one thing to highlight is in particular our open data exchange layer that we basically published in 2014. So when we got acquired from Intel a while ago, Intel thought about building a standard in IT security to communicate via various vendors, doesn't matter which vendor, but over a common security bus. And this is basically what we call data exchange layers, based on the Mosquito protocol, the MQTT protocol. Pretty lightweight communication. It's not like Kafka that is storing messages, it's really just lightweight communication that we leverage to communicate to every single McAfee system. What we decided over the years to open source it. So if you go to GitHub and you look for OpenDXL, this basically gives you access to all the different libraries that we exposed, including the brokers that we open sourced. So the idea was, okay, it's good that we have integration with McAfee and all the McAfee technologies, but what else, right? So I'm as a customer, I don't care if McAfee has a partnership with a vendor to build integrations. I want to build my own integrations. That's the reason why we built DXL. And this is also where we thought that might be a great idea to integrate MISP in particular with the data exchange layer fabric. So if you go up the chain, you can see also there's one of the reasons why we work with MISP platform together, because it's a central place of collecting, aggregating threat intelligence. And we thought, well, what is a process, not working on the platform, but what is a process in security operations to leverage the MISP platform? And this really started by looking at the process to first collect, aggregate, and validate the data that we have. If you leverage open source intelligence, if you leverage community shared intelligence, or if you use local produced intelligence, which is maybe more relevant to the enterprise, that is one of the key and highlights what you have to do first time. And then leverage the threat intelligence not only to enrich it and aggregate it, but also to use it for your security operations team. have you seen any artifacts related to this what we received in the past? So for example, I get an IP address. Do I know if I have seen this IP address in my enterprise the last couple of days, years? Or can we get information of which system executed which file associated to that hash? So this is where you start talking more the hunting and investigation of aggregated and validated data. But also to come to a step where if we have validated intelligence and we know it's bad and it's 100% sure, we have to push it to our key cyber defense countermeasures. And this is what we call the containment actions to update defenses. So to give you some highlights how that looks like as kind of a high-level architecture diagram. So we looked this and aligned to the process. First, how do we collect intelligence? Of course, MISP by nature has a lot of capabilities to share intelligence with from external sources, so leveraging external intelligence. But you see also another one, what we call McAfee ATD is our sandbox. So what we basically do is reproduce threat intelligence. And most of the time we see a sandbox as a tool that is detecting a malware. But see it more as a tool that is producing threat intelligence. And threat intelligence should be aggregated into a central platform. And that is exactly where we basically wrote subscribers on this DXL fabric that takes the information that we produce and automatically ingests them into MISP. So basically the idea is we produce intelligence. Of course we update all the endpoints, it's all nice, but we have to share it also centrally. So what we by nature do, we push out the DXL message, including all the indicators of compromise. We pass them and push them into the MISP platform. Pretty simple, pretty basic, but it's a key point in the first phase of leveraging threat intelligence to aggregate and validate those. And the second was more for validation. So my previous speaker, he talked about validation. So one is leveraging intelligence to push them into SIM solutions, where we automatically go back in history and check if we have seen any artifacts in the past. Have we seen IP addresses? Have we seen domains? Have we seen hashes? And we'll automatically communicate back to the MISP to prioritize those, but most of the time we talk about tagging. So in this case we apply tags as high priority. But one thing keep in mind, if you want to do these checks, you also need to make sure that you collect the right data. So you collect maybe IP addresses and domains, but what about hashes? So what are the data sources that I need to collect hashes? Because most of the time you receive hash information. So how do we make sure that we aggregate those and automatically push them back? So in this case, we automatically transfer them via APIs and sticks, pretty straightforward. But you see at the bottom some others. It's what we call tie and DXL and leveraging active response. So what these are basically EDR solutions. There's an EDR solution, active response, that you see on the right. So what we basically do, we receive intelligence on MISP. We will automatically launch live active response lookups across every single connected endpoint. And we ask every single endpoint, do you have this hash? Do you have this domain connection? Do you have any NetFlow IP address connections? And we automatically communicate this back to the MISP platform. So we automatically add comments, but also tags to the platform. So if you think about this, so receive intelligence, how do we prioritize those? Well, if it's validated, it will automatically flow through this process and will automatically tag the most highlighted and critical artifacts that we need to look at. You see also another one, what we call McAfee ties, nothing else as a local intelligence database, a hash database. But what's interesting, every single endpoint has access to it, and I can automatically get information who executed that file at which time and where on which endpoint. So all this information, what you see, is completely automated, but we call it pre-triage. Maybe you heard about the triage process in SecOps. So this is more a process of prioritizing those. And to give you an example, we have a customer that basically receives 8 million threat feeds per day. And you can imagine, you can put there human, good luck, but you think there must be a kind of process to validate the data up front. And this is exactly the process that they apply. But more compliancy-wise, they go back within 3 years and check if they have seen any IP addresses or hashes within 3 years, which will automatically then bubble up to the platform, will automatically prioritize those. But of course, there's another aspect to that is the containment actions. And this is where we automatically update defenses. I outlined here a couple of vendors. This doesn't matter. Based on the OpenDXL framework that we have, we built more than 150 vendor integrations. Doesn't matter which vendor. At least if they have APIs, we can automatically update them. So we extract the artifacts if they are tagged, and we'll automatically update defenses. So basically, writing IP addresses in block lists in firewalls, or automatically into Cisco ASA, for example, firewalls. Leveraging PX Grid could be an example, or also looking at DNS security solutions like Infoblocks. Why would you ever resolve a domain to an IP when you know the IP is back? So give the system back an annex domain, right? So pretty simple, but this doesn't really happen. But this pretty kind of outlines all the different integration patterns that it should follow, but also it needs to look into the broader process and security operations. So to give you some examples. So let's look at the first use case, leveraging and aggregating threat intelligence. And this is more the process where we leverage the MISP platform to consume threat intelligence that we produce via DXL, but also is able to consume, of course, other intelligence feeds like our APG service or other external feeds and sources. Another process is more for around the investigation, to give you some insight here. So we consume information and push them into our SIM platform. And we automatically check, have we seen this in the past? But we automatically communicate via DXL to our TIE service as well as active response. Really straightforward, just a small description to those integrations that you've seen. Another one is more talking about the containment actions, and this is pretty simple because we're able to update every single endpoint with the intelligence that we have in the MISP platform. But also we automatically integrate those with all our tools that we have. Not only McAfee tools, but also other vendors. So we have also a huge adoption within this data exchange communication fabric, also from other vendors that don't even have a partnership with McAfee, but leverage also these open source tools now. So to give you also some insight, what we've done with customers. And this is kind of a pure real world example, how the MISP platform is used within a McAfee customer. So they consume the information intelligence feed in the MISP platform. Might be from various sources, right? Doesn't matter from where it comes from, could be even local sources. But what we do with that, we have a threat hunter that automatically works on the platform and applies tags to automatically initiate a process to look up every single endpoint, but purely for prioritization. Just to check, have we seen any artifacts right now within my enterprise? But also, if there are systems, we automatically push the intelligence into our SOC, into a SIM tool, where an analyst works and receives an alert that there are specific artifacts found to this system or to this intelligence that we received, where he will automatically use additional components to do additional triage processes and confirm the extent and automatically update defenses. This is purely just an example to show you how it's used and the threat intelligence platform within the enterprise. Another new example is, could we not automate this? And I think you've seen the world of orchestration automation tools. Could we not apply those tools also on top of that process? So that's the reason also why we've built a lot of integration with a platform called Phantom, the MISP, or InterMQ, and so on, so that we could also leverage for that. So how could this look like? So we go through the same process. We receive intelligence feed into the MISP platform. Now we have the same process, but we automatically collect the intelligence from, for example, a tool called Phantom. Phantom will automatically apply playbooks. So in this case, it will automatically reach out to VirusTotal. It will automatically reach out and query our SIM solution. It will automatically reach out to every single endpoint and ask, do we have any artifacts? And will automatically push this intelligence down to all the different cyber defenses. This is really just an example. I can show you quickly the playbook. This is how it looks like on the platform that is actively used. So it collects data from the MISP platform that are tagged, so based on the tagging algorithm. So we consume those, extract them, and we automatically get file reputations, run queries, hunt for files, and automatically push these intelligence down. But you see something really interesting here. Because a lot of organizations are hesitating of automation. You might see this one. This is a human in the loop. So what we basically do is we collect all the data and we ask the analyst, you have to make a decision to automatically contain. Because maybe don't do this automated, and most of the time we want to have the information from an analyst itself. So what this is basically, we give all the data to an analyst that he needs to make a decision. And this is what the most important thing is in security operations. How long does it take you to make a decision? What is all the data that you need to make a decision? And this is exactly what we can automate. So automate all this process, the data collection, the enrichment, up front, and give the analyst the right data that he can take in action. So he basically just says, approve or not, and then we automatically update defenses. That's really a simple example. Another example is from a CERT organization in Europe. So in this case, we have a CERT organization that is managing government agencies. So we have here at the bottom a couple of government agencies that leverage different tools, McAfee endpoints, but also McAfee network sensors. And the CERT is basically managing those agencies. So, and the idea was, what happens if there's a complete unknown file executed within the first agency? Well, what will happen? It will automatically transfer the files to the CERT, and we analyze the files in the CERT, and we automatically push this intelligence down. But you might think, well, the intelligence that we just produced here might also benefit the other agency, right? So before we do that, we need to validate it. So what we do is we automatically push that into the MISP platform, but at the same time we run playbooks to do multi-sandbox analysis. So we grab the original samples that the user submitted or that got automatically submitted from the sensors, and we basically automatically go back to the sandbox, collect the original sample, and detonate those files and tap 5 other sandboxes. So, and then you can think of easy mathematical algorithms to understand and say, okay, is it good or bad? So what happens if McAfee says bad, but all these others say don't? So what happens if all of them say it's bad? So in this point, we have also a human in the loop that automatically says yes and will automatically share the intelligence with all the different agencies. So just to give you here an insight how we leverage the intelligence platform, in particular the MISP platform, so there's a lot of hype right now also in the enterprise. And we've built these architect designs, they are implemented, they're documented, also recorded. You can find online. I just posted here some of the integrations that we published, but most of them are published on GitHub, but also on the McAfee channels. So with that, I come to the end. So just really give you the context, why to put the intelligence platform, where to put it, what is the process to align to that, and how does it leverage in security operations. And to be honest, most of the organizations and workshops that we held with customers is all around leveraging threat intelligence and getting better in leveraging threat intelligence, because you can do a lot with that, but if you don't really effectively use it, it's pretty useless. So in this exact way, you align these architecture designs. All right, I would leave that up. Are there any questions? Thank you. Yes, we query MISP via the normal APIs, extract the information that we get via the APIs, and then we leverage DXL to communicate to all the different McAfee systems. Yes. That was the next question from my side, exactly. So that we should definitely sync on that, yes. Yes. All right, any other questions? Yes. Wow, that is the most exciting thing from my presentation. I'm just joking. I'm just joking. No worries. So should I do an advertisement on that ad? You like it? Well, it's okay. Any other questions? Okay, with that, thank you very much.